Welcome to Plugged In, a podcast by OREMC about our co-op, our community, and our shared connections. I'm Michele Hutchins, your Communications and Marketing Coordinator, and today we are talking about power restoration. So joining me to talk about that is, once again, our Manager of Operations, Travis Page. Welcome, Travis.
Thank you.
So as you and I talked about a little while ago, helping members understand first and foremost how our distribution system, how their power is delivered in the first place is maybe a good first step into understanding how we restore power when it does go out.
Okay. We kind of explain it like this. We could compare it to the road system, to the interstate system. When you leave our substations, the main trunk lines would be somewhat equal to your interstates, your Highway 90.
Your
95.
on-ramps.
Yes. Your I-75s, stuff like that. And as it gets further away from the substation, it tapers down to our two-phase lines and even our three-phase lines, which would be your in relation to your county highways and less traveled two-lane highways. And then as you get further on out into what we would call our rural areas,
The country.
yes, you get down to to our single phase lines, which we could equate to our dirt roads or small pig trails, if you will. That's the further you get from our substations, the smaller the lines get, and the less capacity, I guess you would, and the less customers you serve.
So you have to restore the bigger lines first, because then you really don't know what's out down the line if the bigger line is out. Is that correct?
Exactly. We like to throw our labor and our resources at the bigger lines first, get the most bang for the buck, and then work our way out.
Well, and I think it's important to understand. I mean, obviously, our goal is to not have any outages. But the reality of that is Mother Nature is much stronger than we are. And trees, wires, lightning, they're all things that can cause damage on the system that is beyond our control.
Yes, Mother Nature and Father Time. We do have outages that are caused from just the lifespan of given insulators and wire and poles and things. But yes, Mother Nature is by far our biggest rival, I guess.
And so one time I was having a conversation with one of our engineers, Kane Lee, and he was talking about the SCADA system, which we'll talk about in a little bit.
Okay.
But, as he said then, and we've just talked about, 0 is the goal, but it isn't realistic. So the alternative is, how do we get outages to impact the fewest number of people for the shortest number of time? And that is really where technology has brought us to today and will continue to take us, because power lines and the delivery of electricity has not changed since the system was first built in 1939.
That's so correct. You're still dealing with wire, you're still dealing with insulators and wooden poles for the most part. And that's the main thoroughfare for electricity.
And it's a manual process to both build and repair.
Yes.
Now, as time has gone on, we do more underground lines, not just pole top carry. But while that has many benefits, it can also have challenges when we're talking about an outage, because they are harder to get to, can take longer to restore.
Yes, we have a lot of kind of abstract opportunities, if you will, when it goes to underground. A tree can't fall on a line, an underground line, and really knock it out. But if lightning gets into underground, just like it does overhead, it will short it out. Then the complications can be finding a shorted out piece of wire underneath the dirt or a highway, or even in a lot of cases, we're in the same area whenever we go to install power as your telephone companies, as your gas lines, as your water lines and sewer lines. So we're all there in that same yard.
Space.
In that same space, and it's all under the ground.
So you have to be mindful.
You can't just go find it real quickly. And then you have to be very careful how you dig down and actually make the repairs. So it offers its own challenges with underground. And in this part of the world, we do have a lot of trouble with water and the dampness of our dirt and with lightning.
Because our water table is so
Yes. So
high.
that are some complications that goes with the underground in our part of the world,
Even though it has other benefits.
even though it has
There's
other
trade-offs
benefits. Yes.
for sure. All right. So if zero would be our ideal, but the alternative is the best alternative is the fewest number of people for the shortest number of time. Obviously, technology has brought us a little bit so that we are better at identifying more quickly and isolating outages so that we can reroute power, so to speak. We've got this highway system. When
Yes.
you get backed up on the highway because of an accident, there are ways that you can maneuver around. So we do the same thing with power
Yep.
when we can. But with a severe thunderstorm or a major storm, whether it be hurricane, tropical storm type issue, or even an ice storm, which we have had in the more recent past,
Yep.
The biggest thing is to actually identify what is causing an outage and exactly where it is. So finding it and understanding the cause is really step one. It isn't just about going out there and putting up wires. It's understanding what the issue is that you have to deal with to begin with. And that could be a number of things.
Exactly. Assessing the issue, assessing, how bad is the problem, the equipment that it's going to take to repair the problem, what other logistics is going to be involved, whether you have other utilities involved, whether you have, a broke pole or something that's close to a highway or something where you may need traffic control. There's so many other things that go with that in that assessment stage, that first stage of repairing those outages.
Well, and that does, like you said, it takes time. You don't know what you're dealing with often. You may have a good idea. You don't often know what you're dealing with. I mean, one instance that pops to mind, it was early in the pandemic, and it was near Easter, but it wasn't Easter, where we had that big storm blow through and took down a whole bunch of trees out in your neighborhood, actually, in Hoboken. And I mean, there were just trees down everywhere. We can't even begin to repair something until you remove trees. And depending on the size of things, it can take some time.
It can take a while, and our guys have moderate tools to do stuff like that. They are equipped with chainsaws and they actually have stick saws that they have on their trucks they can take up in the buckets with them. But day in and day out, if we have a sure enough a bad storm come through, we try to call in our right-of-way contractors, our right-of-way folks that are specialized in tree removal.
Yeah.
And we will actually, we've got a crew going to the Hoboken area or to the Brunswick area. We'll try our best to send a right-of-way crew with the correct tools, with the things that they need to open up that right-of-way, to open up that space where our guys can get in there and get the lights back on.
Well, and another example you shared at one point in time when we did have the ice storm in January of 2018.
Yes.
I remember you telling me about Highway 99. Is it essentially that ice storm really did a significant amount of damage to our system along Highway 99 between 82 and back toward Brunswick, and 32, but you couldn't even get to what the problem was because trucks couldn't get down the road.
Yep.
And I remember you telling me that there were guys just going down with chainsaws trying to get the trees out of the way so you could get to understand how much damage there really was.
Yeah, it took us quite a while to actually get to, the source of some of our problems, just because of the amount of vegetation and stuff that was in the roads.
You mentioned that we do the three-phase line first because obviously the goal is to restore power to as many people as possible, as soon as possible. But sometimes that's hard for a person who's been out for a longer period of time, but they're far off that three-phase line. They're down a dirt road, off the 2-lane road and further down. Yet they might be able to see across the field or across the way that somebody else does have lights on, and they don't understand why. Can you explain why that might be in the sense that different lines and different circuits feed people from different directions, and why we're really not addressing your issue, but we have to get to those bigger ones first, and you have to understand where your power is coming from.
I'll do the best I can. When it comes out of the substation, as we've talked about it a couple of times, those lines are three-phase lines. Those lines are, we call them A, B, and C. I mean, as they go out through our system, they drop off, if you will, to the individual taps, the individual roads, the individual subdivisions. You could have your main trunk line on. We could get the three-phase line A, B, and C back on, but then as the power line would take off of the road, then you have a breakdown on your particular issue. So yeah, at the main road, you've got neighbors and other customers that may have power, but your specific road, your specific driveway, even though it may be close to the substation, it is on a single-phase type device, and it may still be off, and it may have a damage that may take hours to fix. To get one customer back on. And like we pointed out before, we try to get the most bang for the buck. If we could send a crew out to get, 1,000 customers on in 2 hours, or we could send a crew out to get a small tap that only has 2 or 3 houses at the end of it, it's kind of a no-brainer. It is part of the advantage you have to live in rural South Georgia. It's a blessing, to live in the part of the world we live in. But when we do have a major storm or whatnot, and we're calling in other resources, other contract crews to help us, or other fellow EMC co-op guys, we have a certain call list or whatnot. We go through our statewide, and we'll get linemen from North Georgia, from West Georgia. We'll get linemen from the neighboring co-op, Satilla or Colquitt. When they come to help us, in likewise terms, when they have issues, we go and help them. And what I was alluding to there is when we go to these other co-ops, it doesn't matter where we're at. We're getting asked by the customers the same thing that we just talked about.
Right.
Well, why do my neighbors have power and I don't?
I don't.
So yeah, it's the same mentality, the same philosophy that everybody tries to do. Let's get the majority on as quick as we can, the biggest bang for the buck, and then we'll come back and tidy up these loose ends.
And that's really the purpose of this podcast, is to help you understand why that does occur and why we do understand it. It is frustrating for those that kind of the last to be brought back on. It all has to do with location and what else is going on in the system.
Exactly.
Because we approach it from a system-wide.
We do.
Thing.
You have to look at the big picture.
So we mentioned a little earlier that the process of delivering power hasn't really changed since 1939 when we first started to build the system, but technology has played a part, enabling us to better identify or isolate where an outage is occurring on the line, as well as hopefully allowing us to isolate that and then minimize as few people as possible. Can we talk about that a little bit and how that's made a difference? I mean, it's basically a communication system with devices on smart, intelligent electronic devices on our line. Both in our substations and in certain locations on our lines that trip, if you will, and give us information as to about where an outage is occurring. What then does that enable us to do that we couldn't do, say, 15, 20, 25 years ago?
Yeah, the technology you're talking about there it enables us through the basically the weight of the fault that caused the outage. And I'm not an engineer, but they can run that fault current analysis through the computer system, and it will give them, and it's surprising how accurate it is. We can have a tree fall on the line 10 miles from the substation, and when the system operators get through diagnosing the issue, while they're in the process of calling the lineman, saying, hey guys, I need y'all to come to work, I have a circuit out, and that dispatcher, that system operator, he goes into his analytical mode, if you will, and he punches the information into the computer that's coming back to him, and 9 times out of 10 on large outages, we can tell, the system operators can tell a lineman within 300 or 400 yards of where the outage, the probability of the outage being. It's really different from back when I started. June, I'll be there at the co-op 34 years.
Wow.
But whenever I first started out, and I come through system operations as well, you gave a guy a line and said, "Look, this road's out, or this three phase is out," and he started with his back at the substation, and he drove and he rode and he walked, systematically down the stream from the substation
To find it.
to find what the problem was. It saves a vast amount of times for us to be able to say, hey, go to pole so-and-so, 1, 2, 3, 4, 5. It should be within 200 or 300 yards of this substation. I mean, of this pole, this intersection. It is really amazing to be able to go from the old, I guess, non-technology, if you will, to where we're at now. We may not can always keep an outage from happening, but the response to that outage has really really grown.
And then the other part of that is being able to redirect power. So
Yes.
when you isolate that, yes, it might, it might affect not the whole road. So
Yeah.
you can isolate it like, okay, so we can bring it down to just this number of people, but from here back, we can feed them power from another direction.
Exactly.
And
we have
redundancies on our system. That's part
Absolutely,
of that
and
hardening we talk about.
yes, and every year we do the engineering staff, the engineering department, they do studies on where would be the best places to put these devices so we can open lines, so we can redirect feeds. I mean, that's a constant research development that goes on, weekly, daily. Even if we have outages and we run into a problem, and this outage took a little longer than what we thought it should be to restore, that information gets pumped right over to Kane, which is our reliability engineer. And he'll sit back and he'll do a study on it to figure out, well, if we had a switch there where we could open that line up and, we could redirect this from a different substation or a different circuit, it would make things, it may not shorten the outage for that particular issue. It may not get that tree off the line any quicker, but if we can isolate that problem and redirect power, then the vast majority of the customers can be got back on.
Well, and I think that's the other issue that we really need to touch on is trying to reduce outage times. It happens long before an outage potentially even happens. So yes, technology helps us identify more closely as to exactly where it is so that we can get there quicker to figure out what the problem is, because you still don't know exactly what the problem is until you get there and lay eyes on it.
Yep.
And we can reduce the number of people impacted. But the other part of that, we've used the word storm hardening. Well, storm hardening is really about ongoing regular maintenance and updates. And then you also hear about right-of-way maintenance, managing our right-of-ways. Those are things that happen all the time throughout the year. Talk about why those everyday tasks, if you will, for lack of a better phrase, part of the everyday lineman's work are equally as important to helping prevent an outage when the storms blow through as it is responding to it.
Yeah, we Michelle, we measure outages in two ways. We measure outages in the number of outages, and we measure outages in the duration of how much time each customer, the average waited time, does each customer have that they're out, and like I say, versus how many times that customer was out throughout a year.
Sure.
And those are the measurements that we, the indices that we keep track of this, and we've got tons of data that goes in all that. But as you're talking about the right-of-way programs, the maintenance programs that find our weak spots, if you will, and try to improve those, the storm hardening. Right-of-way in particular is a big issue. In South Georgia, North Florida, where we're at, a lot of times we'll have an 11-month growing season, 10-month, 11-month, because we don't have any winter.
Trees get tall.
They do not go dormant like they do in middle and North Georgia and even further on up the country.
Yeah.
So we have a 10-month growing season down here. Our right-of-way, the trees are growing 10, 11 months out of the year. It's hard to stay ahead of that if you don't really have an aggressive right-of-way program. A lot of our stuff is rural. With that being said, there's a lot of trees involved.
Right.
Um,
Which makes it nice to live where we live.
oh yeah, so, it's a blessing to live down here in South Georgia where we have trees and woods, and but it is a double-edged sword.
So
It causes problems.
keeping them maintained and open is a key. One of the other things we often notify members about throughout the year is when we're doing pole inspections.
Yes. Yep.
So that's another part of it. I mean, poles are trees.
We inspect about 10% of our poles a year, and that's some guidelines set by your state governments and stuff like that. And in our maintenance programs. So we roughly have 65 to 70,000 poles on our system. We inspect between 6 and 8,000 a year. We hire osmosis that comes in. They tap the poles. They drill the poles. If there's anything that looks rotten or looks damaged, we turn them in and we get them changed out. We've just got our latest report from Osmos, and last year it was less than 1%.
That's fabulous.
We actually were considered reject poles. We have them on scope now to have them changed out. There's 94 poles that we've got on a list. We're fixing to get them through engineering, through staking, get them rode up. My guys will go change them out so that whether it's a pole that the county has come by repeatedly with a mower and bumped the side of that pole, and they've chipped a good hardy pole, but it's been chipped away by mechanical damage, or whether it's down here in this part of the world we have a lot of woodpeckers. Mm-hmm. Woodpeckers love our poles, and I don't know if it's the vibration from the power or what, but yeah, you don't have to look far till you see poles with holes in the top of them, and we have to change those out because tops will just break out. And then we've been here 80 years. We have a lot of poles that haven't been changed out in 30, 40, 50 years, and you do have some ground rot because of the moisture and whatnot. And, they do all the tests and certify what they do. And we try to stay on top of that.
Right. But it's all part of our proactive
Absolutely.
approach to.
There's a plan. There's a method to the
madness.
madness.
To absolutely, working to, again, reduce the incidence of outages, again, Mother Nature and Father Time certainly, take their toll here and there.
It's twofold. It's being proactive and trying to stop the outages as much as we can before they happen. But then it's having the SCADA to help you when you're trying to be reactive to an outage, being able to tell where the outage is at. It even goes back to your labor and your materials, your equipment and stuff. We have gradually upgraded our equipment, our pole trucks, our bucket trucks, to the point we have a very good fleet right now. We have machines that can help us get to where we need to get and get the lights on as quick as possible. We keep X number of people on call. They're on standby. In the afternoons, at night, on the weekends. At any point in time, we may have 12 to 15 people that's available, that's standing by for an outage call. They're equipped with vehicles at home where they can go straight from their home to respond to an outage quicker. And those guys are scattered out throughout our system. We have other folks that they volunteer to basically be on call, and they'll call the system operators and say, look, I have nothing going on this weekend. Looks like there's a storm, coming this week. If you need me, call me. And they'll go to the office, pick up the equipment, and go help the ones that are on call. So all of that's being, both proactive and as reactive as we can to reduce the duration of these outages.
And I'd just like to end with, much like we are constantly preparing and shoring up that we have people in place, that we have equipment in place, that we have supplies in place to be able to respond, so too does your family need to prepare. You need to have your own plan as to what's going to happen. We do live in a place where hurricanes and tropical storms can happen. We have seen mass evacuations, particularly of Florida, not that long ago. Knowing where you're going to go. Are you going to shelter in place? Are you going to shelter locally? Do you have to get out of the area? Have you put together your emergency preparedness kit so that you have what you need, you can pick up and go for you, your family, your pets? All that is part of being prepared for the hurricane season and weather ready at a moment's notice because of where we live. So just as we are preparing, we encourage you to prepare as well. And I'll refer you to ready.gov if you need information on how to write your plan, the things you need to consider, and what you should put in your kit. So hopefully preparation is the best prevention, Travis.
Maybe so. Maybe we'll have a perfect plan and it never gets used.
And but again, we are committed to powering your lives every day, and when the lights do go out, we are committed to restoring that power as quickly and as safely as we can.
Absolutely.
All right. Well, thank you.